Welcome back to ENS161 Statics of Rigid Bodies. So this is now Module 6 Moments of Inertia. So for this lesson, we will be discussing moments of inertia and related concepts. So hopefully by the end of this module, you should be able to understand and determine moments of inertia of various areas with respect to given axis, understand polar moment of inertia and parallel axis theorem. So this is all used to determine the moment of inertia of various shapes. So consider a distributed force F, so this, whose magnitude is delta F, are proportional to the elements of area. So from the previous chapter natin, no? So sa um, So in determining the centroids, we have tackled there that the delta weight, so the delta weight is equals to or proportional to delta area, no? So dito natin kukunin yung concept natin for this moment of inertia. So weight is a force, so this is also a force. So the delta F is proportional to the elements of delta area. So at the same time, so force acts on delta A. This also varies linearly with respect to the distance from A to a given axis. So you have, say you have x-axis here. So the force varies with respect to um, uh, relative to y. So the further the force from the x-axis, the greater the value. Of course, kasi multiple natin yung y. So meaning, at the axis here, 0 yung magiging force natin. So consider for example, we have an I-beam here. So with uniform cross-section which is subjected to two equal and opposite couples applied to each end of the beam. So we have forces. So meron tayong force, compressive force dito and tensile force sa baba. So and with the neutral axis here. So pag ganito yung scene, this is what you call a beam to be in pure bending. So pure bending siya. So this couple, so with respect to the x-axis, this create a moment, no? So moment is parang binibend or tinitwist niya yung object. So this beam section is in pure bending. So say we have a beam here which is simply supported and with load P sa center. So when the beam is loaded, so pag concrete siya, hindi mo makikita yung changes, no, pag may loading. But for example, this is a wooden platform na lang. And then may support siya sa both ends and may papatong ka sa gitna or tututong ka sa gitna. And then the platform would bend ng paganyan. So parang bend siya pababa. So this is the internal reaction dun sa beam. So when you load a beam, it will deflect downward. So if you cut the section sa gitna, so at the middle, so this section, so for example, this is a rectangular beam. So it is subjected to a, so the forces acts on this surface or on this cross section is the resultant will be a compressive force sa taas and tensile force sa baba. So that is why with respect to neutral axis, para magkakreate siya ng bending ng moment. Parang ganyan. Magkakreate siya ng moment. No? So this varies. So since this is a force over area, so this varies linearly with respect to neutral axis. Pag ganyan. So pinakamalaki yung force sa taas, which is compressive and tensile sa baba. So ganyan, no? So for example, this cross section, so pupunta dun sa neutral axis. So relative to y, sa neutral axis is 0 yung magiging force. So it is shown in the mechanics of materials that the internal forces in any section of the beam are distributed forces whose magnitude delta F is equals to K constant Y times delta A, and vary linearly with the distance Y between the elements of the area passing through the centroid of the section. So this axis represented by x-axis is the neutral axis. So neutral kasi sa on that section is 0 yung forces. So not compressive, not tension. So 0 yung forces dyan. So dyan neutral yung mga forces. So the magnitude of the resultant, which is R, of the internal forces delta F that acts over the entire section is equals to the integral of ky dA. So integrate natin yung delta F. So this is summation of F is R. So magiging K times the integral of y dA. So this integral, the last integral here is the, if familiar kayo, this is the first moment of inertia. So first moment of, the first moment of an area, which is Qx. So this with respect to x-axis is equals to y bar dA. So now, since the x-axis is located dun din sa neutral axis, so y there is equals to 0. So meaning, the first moment is equals to 0 here. So the magnitude, so the system of the forces, delta F, thus reduces to a couple. So meaning couple na lang siya. So this is a couple moment, no? So couple moment is, meron tayong so meron tayong ganyan. And then merong force dito and also force dito. So this create a moment. So yan yung couple moment. So this is this distance D and this is D. So a moment with respect to a point, meron silang same distance. So yun yung couple na moment. Will then be equal to so the magnitude of these moments of this couple, which is bending moment, must be equal to the sum of the delta moment, which is equals to y delta F. So since delta F is equals to ky delta A, so this will be equals to, substitute natin yung value, magiging ky squared delta A. So the magnitude of the delta M, so is integrate natin yung both equation. So the moment is equals to the integral of ky squared dA, which is equals to k is constant, so ipapalabas natin sa integral, so magiging y squared dA. So this y squared, integral of y squared dA here is the second moment. So first moment is y, and second moment is y squared. So this is our commonly known as the moment of inertia, which is usually designated by a variable I. So capital I. So with respect to x-axis, this is Ix. So moment of inertia is obtained by multiplying each element of area dA by the square of its distance. So that is y squared with respect from the x-axis and integrating them over the beam sections. So since the moment of inertia is y squared, so regardless of the value of y, moment of inertia will always be positive. So the value will always be positive, no, kasi y squared. So that is how you how you determine yung second moment, or yung moment of inertia, the integral of the y squared multiplied by the area. So determination of the moment of inertia of an area by integration. So just like the previous natin na module, you will determine the centroids by integration. And also this time you will also determine moment of inertia by integration. So we define the preceding section the second moment, or moment of inertia of an area with respect to x-axis. So um, that is ix is equals to the integral of y squared dA. So similarly, with respect to y-axis, iy is equals to integral of x squared dA naman. No? So these integrals are also known as the rectangular moments of inertia with respect to an area. So just like the previous example natin, you're evaluating an integral of an area, evaluating an area by integral. So this can be easily done if we choose dA to be thin strip parallel to one of the coordinates. So we'll compute the moment of inertia via thin strip, no? So ganito siya. So parang yung ano din natin, yung centroid, determining a centroid. So we'll choose a strip parallel to a axis. So this could be parallel to x-axis and parallel to y-axis, and then you will evaluate the integral. So as an example, so we'll determine the moment of inertia of a rectangular area. So we will determine the moment of inertia of the rectangular using the um, formulas and with respect to its base. So that is the x-axis. So we will select a dA which is equals to b dy. So b is the length and the thickness of the area is a delta differential element y. So the distance from the base to the dA is, say, y bar. No, y. So this is y. So since dA is equals to b dy, so using the equation we have here the integral the moment of inertia of with respect to x-axis is equals to integral of y squared dA. Okay, so since dA is equals to b dy and y magiging integral of y squared b dy. So papalabas natin yung b since this is a constant. So magiging b integral of y squared dy. So what is the integral of y squared dy? So magiging b y cubed over 3. So this is evaluated from 0 to h. So this is the maximum ng y is yung h natin. So the moment of inertia with respect to x is equals to b h cubed over 3. So this is the moment of inertia of a rectangle. So this is fixed na yan, no? So as long as it is rectangle, ito yung magiging moment of inertia niya, bh cubed over 12 or 1/3 bh cubed. So that is the moment of inertia. So yun lang. So you just evaluate the integral, get the moment of inertia, and this is always positive. Next is the polar moment of inertia. So polar moment of inertia is given by this equation. So J sub O. So when you say polar, meaning it involves radius, angles, and yung center. So O is the origin, and J is the variable for polar moment of inertia, which is equals to the ganun din yung form ng equation. So r squared times dA. So this integral is the polar moment of inertia of the area with respect to the pole O, or yung origin O. So this is important, especially for problems concerning the torsion of the cylindrical shafts, and in the problems dealing with the rotation of slabs. So this is important. For example, you have a cylindrical shafts. So you have a cylinder, and with respect to the pole here, sa origin niya, meron tayong moment. So parang tinitwist mo siya. So this time, yung previous natin is bending. But this time, twist na siya. Parang ito-twist mo yung shaft natin. And also, kasi sa building, iba-iba yung mga forces na mayroong bending, mayroong compressive, mayroong tension, mayroong ding torsion. So that is the torsion. So parang moment on the surface, no? So torsion. So this is present sa mga cylindrical shafts, and also sa slabs din meron ding rotation of slabs, meaning yung torsion. So the polar moment of inertia is given, inertia of a given area can be computed from the rectangular moment of inertia. So so say there's just an area, and at this origin pole is yung area natin is parang iikot siya. So but at this dA, meron tayong coordinates na x and y. So from the formula, J sub O is equal to the integral of r squared dA. So r squared here, so using the Pythagorean theorem, r squared is equal to the x squared plus y squared. So substitute natin yung value. So this is the integral of x squared plus y squared dA. So magiging integral of, so isa-separate natin. So magiging x squared dA plus y squared dA. So these two are the rectangular moments of inertia. So we can denote that the polar moment of inertia with respect to the origin is equals to the moment of inertia with respect to x-axis, and the moment of inertia with respect to y-axis. So ganun lang. It's just the summation of the x and y-axis na moment of inertia. So yun yung polar moment of inertia. So next is the radius of gyration. So we will consider an area which has a moment of inertia ix with respect to the x-axis. So with respect to x-axis, of course, meron itong moment of inertia. This area has a moment of inertia. So let us imagine that we concentrate this area into a thin strip parallel to x-axis. So concentrate natin yung area na to at this area with respect to x-axis. So if the area that's concentrated, so we still have the same moment of inertia and area with respect to x-axis. So same moment of inertia, and this area is placed at a distance kx. So this kx, no? So which is defined by the relation I squared is equals to kx squared a. So parang yung y natin is magiging k. So Rearranging the equation, kx will then be equal to the square root of ix over the area. So this value here is the radius of gyration. So yan yung radius of gyration. So this distance kx is referred to as the radius of gyration of an area with respect to x-axis. So similarly, with respect to y naman, so if you were to concentrate this area into a vertical strip, so this distance is the area away from y is ky. So iy is equal to ky squared a. So ky is equal to the square root of iy over a. So sa ano naman sa polar naman, so the radius of gyration ko, k sub o. So j sub o is equal to k sub o squared over a. So ko is equal to the square root of j sub o over a. So we can also denote, so since the so we can rewrite the equation ko is equals to k sub x squared plus k sub y squared. So ganun. Okay? So yan yung radius of gyration. So usually naka-formula na siya. Okay, so let us solve for the radius of gyration of a rectangle. So radius of gyration is equal to the square root of the moment of inertia over the area. So the moment of inertia with respect to the base or the x-axis for a rectangle is base cube over 12, which we have solved earlier, over the area, which is base times height. So evaluating this equation, matitira lang is h squared over 12. So the square root of h squared is h, and square root of 3 is 3. So h over square root of 3. So kx, which is equal to, so if you in decimal form, 1 over square root of 3 is 0.57 h. So this is greater than the y bar, which is 0.5 h. So kx is related to the second moment of inertia, moment of inertia, and the y bar is related to the first moment. So radius of gyration is not usually located doon sa centroid ng area. So this is in the case of a rectangle, it is slightly above the y bar. So yan yung radius of gyration ng rectangle. So next is the parallel access theorem. So consider the moment of inertia I of an area with respect to an axis AA bar. So the area with respect to AA bar at distance y, yung moment of inertia natin is I is equals to the integral of y squared dA. So, and then let us now draw a through the centroid a new axis, which is BB prime, which is the centroidal axis. So denoted by y bar from the area. So meaning we can rewrite that we can say that y is equals to y bar plus d. So we'll substitute that to the equation. So magiging integral of y prime plus d quantity squared. So that is the value of y multiplied by the area. So evaluating the equation, so y bar the y prime plus d squared is equals to, that is y prime squared plus 2y prime d plus d squared, no? So we will separate each with an integral. So magiging ito na siya, magiging the integral of y prime squared dA plus 2d, so this is constant, so we will take out of ilalabas natin siya sa integral, 2d times integral of y prime dA and plus d squared delta integral of dA. So this first part of the integral is the moment of inertia with respect to BB. That means the moment of inertia at the um, centroidal axis. So that is I bar. And for the second integral naman is the first moment with respect to BB. So since BB or the centroid is located on this axis, so meaning our y here is 0. So meaning this equation is 0 na siya. So the first moment is 0. And the third integral is the total area of the section. So finally we observe therefore we have I, so inertia is equals to the moment of inertia with respect to the um, centroidal moment of inertia. So moment of inertia with respect to its centroid is called centroidal moment of inertia plus area times d squared. So this formula expresses that the moment of inertia I of an area with respect to any given axis, so putting away from the area or above the area, is equal to the moment of inertia I bar of the area with respect to the centroidal axis BB prime, which is parallel to AA prime, plus the product of the area and the square of the distance d between the two axes. So parallel axis theorem, so you should have a parallel axis, which is AA prime and BB prime. So the distance between them is d, so that is d squared. So yan yung so this theorem is known as the parallel axis theorem, no? So first point is the centroidal moment of inertia I bar of an area can be obtained by subtracting the product AD squared. So if you have the for example yung rectangle kanina, no? So we have the moment of inertia with respect to its base, which is the x-axis. And if we want to determine the moment of inertia of the rectangle doon sa centroid niya is we only have to subtract um, the I by AD squared. Then we can determine the centroidal moment of inertia ng rectangle. So, yun lang. So, you can interchange these equations by determining the moment of inertia with respect to an axis or moment of inertia with respect to the centroidal axis. So, the parallel axis theorem can be applied only if one of the two axes involved is centroidal axis. So, if aside from AA prime, kung meron bang isang axis is for example sa taas niya is hindi mo solve yung say CC. So CC and AA hindi mo solve, hindi applicable yung moment anong parallel axis theorem. So one of the two axes must be the centroidal axis. So ito, this must be strictly the centroidal axis, no? So the I naman is kahit saan siya na axis. It could be axis here, axis there. So as long as one of the two axis is the centroidal moment of a centroidal axis. So substituting k squared a. So this is for the radius of gyration. So k squared is equal to k bar squared plus d squared. So J sub O is equals to the J bar C plus AD squared, and also, so these are the equivalent na mga equations then using the polar moment of inertia and radius of gyration with the parallel axis theorem. Okay, so let's have an example. So first is we will determine or apply the parallel axis theorem in a circle. So I t, or the with respect to the t axis here, is equals to I bar plus AD squared. So the moment of inertia at the centroid of the circle is equals to 1 over 4 pi r squared. So this is we have tables showing the moment of inertia of a common geometric shapes, no? So plus the area, which is pi r squared, times the distance, which is the radius, r squared. So the moment of inertia of a circle with respect to the t axis here is equal to 5 over 4 pi r to the power of 4. So yun lang. So evaluate lang yung equation. So you just have to understand yung concept ng parallel axis theorem. So for example, here we have a rectangle. No, not triangle. So triangle is the center of triangle is located 1/3 away from the base, no? So we have here I with respect to AA prime is equals to the I bar, or the centroidal moment of inertia, plus AD squared. So we want to determine the centroidal moment of inertia of a triangle. So we are given with the moment of inertia with respect to its base. So that is 1 over 12 BH cube. So minus area, which is 1/2 base times height, multiplied by d squared, or the distance is 1/3 h away from the base squared. So the moment of inertia, or centroidal moment of inertia of a triangle, is 1 over 36 BH cube. So say we have an additional axis DD prime, no? So DD prime. So we are to determine this moment of inertia with respect to this axis. So we have now solved the centroidal moment of inertia. So magiging plus AD prime squared. So the distance between the axis is D prime, which is 2/3 h. So for this problem, for example, you are to determine the moment of inertia at DD prime, but you are only given with the um, moment of inertia at the base. So first to get the moment of inertia with respect to the DD prime, you must first get the moment of inertia at the centroid. So using moment of inertia at AA prime, masasolve natin yung BB prime na moment of inertia. So we can now then solve the DD prime na moment of inertia. So that is 1 over 36 BH cube, which is the central moment of inertia of a triangle, plus area, which is base times height, over 2 times 2/3 h squared. So the moment of inertia with respect to the tip of the triangle, the axis, DD prime, is equals to 1/4 BH cube. So ganyan yung pag-solve natin ng moment of inertia. Okay, so we have here a moment of inertia of common geometric shapes. So we have rectangle, triangle, circle, semicircle, quarter circle, and ellipse. So these are all given, no? So these are all known sa mga problems. So we have the centroidal moment of inertia with respect to x and y axis, and the polar moment of inertia with respect to c. So that is the same for the triangle, circle. So yung kanina ginamit natin, no? Centroidal moment of inertia of a circle is 1/4 pi r to the 4. So for a semicircle, quarter circle, and ellipse. So you have to be familiar with this given na mga known na mga equations. So this is the properties of a rolled steel shape. So this is I-beams, not so this we usually say call this I-beam. So this is for this beam we have a W shape or wide flange beam. So this is the most common use natin sa mga problems. So this sa Philippines, ito yung pinaka-usual na ginagamit ng mga I-beam. So wide flange shapes. So meron siyang numbers. So, depende sa type. So, meron tayong properties given, which is the area, depth, yung width, yung moments of inertia, yung radius of gyration, yung y bar, with respect to x and y axis. So, ito. Okay. So, this is also the C shapes and the angles. So, given lahat yung mga properties niya. Okay, so let's have a sample problem. So, sample problem 9.5. So, determine the moment of inertia of the shaded area with respect to the x-axis. Okay, so this is a composite area, no? So, composite yung area natin. So, as you can see, we have a rectangle and semicircle, which is deducted na semicircle doon sa rectangle. So, ganito magiging process natin. So, first is a rectangle minus a semicircle, then it will result to this kind of area. So, meaning, just like yung determination ng centroid natin of a composite area, isa-separate natin yung composite area into its corresponding na mga areas. So in this case, we have rectangle and semicircle. And then, ilalagay natin yung magiging sign nila. So positive yung rectangle and negative yung semicircle. Since this is a parang kumbaga whole siya if ever. So this is a deduction from the area. So, we will determine yung moment of inertia ng x, anong rectangle, and moment of inertia ng semicircle. So, we have mentioned that the moment of inertia is always positive, no? Moment of inertia is always positive. But in the case of a composite area, so pag meron tayong holes, meron tayong mga ganito na mga areas, magiging negative yung moment of inertia niya, of course. Kasi, i-deduct natin doon sa moment of inertia ng rectangle, yung moment of inertia ng semicircle. Kasi yung area niya is negative mismo. Okay. So, first is, we will solve the moment of inertia of a rectangle. So, sa previous na natin is, na-solve na natin yung moment of inertia ng rectangle, no? So, we have here, so the moment of inertia of a rectangle is 1/3 BH cube. So we have here 1/3 times B is 240 mm times the height is 120 mm. So the moment of inertia of a rectangle cube is equals to 138.2 times 10 to the power of 6 mm to the 4th. So the unit of moment of inertia is mm to the power of 4. So to the power of 4 siya. So that is the moment of inertia of a rectangle. So next is we will determine the moment of inertia of a semicircle. So first we will determine, we will solve yung mga yung mga A and B natin. So sa A, so sa centroid, so this is a given. So the centroid of a circle with respect to its base, so with respect to AA prime is equal to 4r over 3 pi. So this is a given, no? So we have 4 times radius, which is 90 degrees. So the radius natin is 90 degrees, 90 mm. So we have 4 times 90 over 3 times pi. So area is equals to A, distance A here is equals to ilan? 38.2 mm. And then sa B, so we have a B here. So this is 120, no? So this is 120, this distance. So B natin is 120 minus A. So 120 minus 38.2 mm. So B is equals to, ilan yung B natin? 81.2 0.8 mm. So we need to solve this first kasi this will be the distances when you use parallax theorem. Distances ang gagamitin natin. So yung sa AD squared na part. Okay. So referring to the figure, we will now compute the moment of inertia of a half circle with respect to AA prime. So katulad ng triangle kanina, we need to solve the centroidal moment of the moment of inertia with respect to x-axis. But the moment of inertia with respect to centroid or x prime is unknown pa. So we will solve muna the centroid of moment of inertia, the moment of inertia at the centroid with the AA prime para ma-solve natin yung I bar natin. And then we can solve the moment of inertia with respect to x-axis. Okay, so we are given with the the moment of inertia with respect to its base. So this time base natin is AA prime. So this is equals to yung kanina 1/8 pi r to the 4. So given to kanina, no? So 1/8 pi times radius is 90 to the power of 4. So this is then equal to, so 1/8 pi times 90 to the power of 4 is 25.76 times 10 to the power of 6 mm to the power of 4. So that is the moment of inertia with respect to the base or the AA prime. So using the formula, independence of area, no? So area is equals to pi r squared over 2. So this is the area of a semicircle. So pi times 90 squared over 2. This is equals to 12.72 times 10 to the power of 3 mm squared. So yun yung area natin. Okay. So sa Parallax's theorem, IAA prime is equals to the IX prime, so the centroidal moment of inertia, plus AD squared, but the distance is yung A natin. So AA squared. So this is, so magiging equation natin is, so to determine the centroidal moment of inertia, so we will subtract AA squared from the IAA. So we have IAA, which is equals to 25.76 times 10 to the power of 6 mm to the 4 plus minus area, which is 12.72 times 10 to the power of 3 m squared times the a squared, which is 38.2 squared. So this is mm squared, so magiging mm to the power of 4 na siya lahat. So we can solve that the centroidal moment of inertia of a semicircle is equals to ilan? 7.20 times 10 to the power of 6 mm to the power of 4. So this is the centroidal moment of inertia. But we are looking for the moment of inertia with respect to x-axis. Okay, so the moment of inertia with respect to x-axis, so the moment of inertia with respect to x is equals to the centroidal moment of inertia plus a, this time yung d natin is yung b na naman, ab squared. So we have here 7.2 times 10 to the power of 6 plus area is 12.72 times 10 to the power of 3 times b squared, which is 81.8 squared. So the moment of inertia with respect to x natin is equals to 92.3 times 10 to the power of 6 mm to the 4. So yan yung moment of inertia with respect to x natin. So now we have solved for the moment of inertia with respect to x for the both areas. So we now solve for the moment of inertia for the total area na. So magiging ano na siya? So the moment of inertia for the area, yung gantong area, is equals to, isa-subtract natin yung moment of inertia ng rectangle and yung um, semi half circle. So this is 138.2 for the rectangle minus, so dito na maging negative yung moment of inertia. So ma-minus lang siya kasi negative yung area natin. So but in general, positive talaga yung moment of inertia with respect to a given area. But sa composite, so depende na sa area times 10 to the power of 6. So the moment of inertia of the composite area is equals to 45.9 times 10 to the power of 6 mm to the 4. This is the moment of inertia. Okay, so ganun lang. So it is a step-by-step process. So for composite area, we will get the moment of inertia for the required at the given axis one by one, and then isi-subtract mo na lang yung magiging when it's solving yung total na moment of inertia. Okay, so another sample problem, which is 9.4. So the strength of a wide flange beam, which is W 14 by 38, is increased by attaching a 9 by 3.8 inches plate to its upper flange as shown. So we have here a I-beam, and then naglagay ng plate sa taas to increase the um, strength. So meaning yung centroid na is wala na doon sa center ng I-beam. So somewhere sa above na siya, no? So nag-shift na yung centroid kasi composite area na siya. So determine the moment of inertia and the radius of gyration of the composite section with respect to an axis which is parallel to the plate. So meaning ganito siya na axis, no? Parallel siya. So somewhere x axis siya. And passes through the centroid of the section. Okay, so we will determine now the moment of inertia. So this is the centroid. So given tayo ng centroid, but wala pa tayong alam yung location, hindi pa natin alam yung location ng centroid niya. So we will determine the centroid muna, and then the moment of inertia na. So kunin natin yung moment of inertia daw at this axis that is passing through the centroid of the plate. So this wide flange beam here is, ito siya, no? So meron siyang area na 11.2 inch squared, depth 14.1, so which is given, and then 6.77 width, and moment of inertia with respect to x na 385, and radius of gyration with respect 5.87. But this is only for the I-beam. So since meron tayong added na rectangular plate here, so mag-iiba na yung values natin, moment of inertia, radius of gyration, centroid, kasi composite na siya. Okay, so ito na siya, no? So with respect to the center, so first we will determine the centroid, no? So taking the center of the flange as O, so that is x-axis, and we will determine the x prime na axis. So we'll first solve for the area and yung y bar ng plate natin. Since we are given with the area and y bar ng wide flange, so we'll solve naman for the plate. So for the plate, we have an area which is equals to 9, since rectangular siya, so 9 inches times 3/4 inch is 0.75 inches. So this is equals to 6.75 inch squared. So the y bar naman niya is equals to, so this is with respect to the centroid no ng wide flange natin. So yung y bar is kalahati, so 1/2 ng 14.1 inches plus kalahati ng 3/4 inch. So doon yung centroid ng plate natin. Okay, so that is 1/2 also ng 0.75 inches. So the y bar is equals to 7.425 inches. Okay, so yan yung y bar and area ng plate natin. Okay, so we have now the, since this is a composite, so to determine the centroid, tatabulate natin. Okay, so this is with respect to the center, no? Okay, so, but also you can solve with respect to this base, but para mas madali siya, so with respect to the center ng flange na yung the way we will solve this. So for the wide flange shape, so yung area niya is 11.2 and the y bar, so 0 na siya, no? So mas madali na siya kasi dito natin nilagay yung axis muna natin. So 0 yung y bar, and then the y bar times a, of course 0 then. So for the plate, y bar times a is equals to 50.12. So the total area is equals to 11.95, which is all positive, and then the total y bar times a is 50.12. So the formula for the first moment is y bar summation of area is equals to the summation of y bar times area. So for this is for the composite area, no? So we have here to determine, we'll determine this y bar here. So this y bar is ito siya. This y bar. So the summation of area is 17.95 and the summation of y bar a is 50.12. So we have y bar is equals to, this y bar for the composite area now, 2.795 with respect to this axis. So yan yung location ng y bar natin. So we will now solve for the moment of inertia of the wide flange beam. Okay, so for the moment of inertia of the wide flange beam, so we have here with respect to x, no? With respect to x prime. This. So dito na hanapin yung moment of inertia. Centered ng composite na. So ix prime is equals to the I bar x plus a. So yung distance natin is y bar squared. Okay, so this is equals to, so we are given with the moment of inertia of a flange with respect to its centroid, so which is 385 inches to the fourth plus a is 11.2 times y bar is 2.792 inches. So this is equals to 472.3 inch to the power of 4. So that is for the wide flange, no? Ix prime. So for the moment of inertia ng plate natin, So for the plate naman, with respect to the centroidal, with respect to the centroid ng composite area is the I bar x plus a, which is distance natin is yung d, ad squared. So this is equals to um, so sa mga sa properties kanina no ng common geometrical shapes, the centroidal moment of inertia ng rectangle is 1/12 base times height. So base natin is 9, bh cube. So h natin is 0.75 inches, no? Plus area, which is 6.75 times the distance, which is, so the distance ng centroid natin, distance d is 7.425 minus yung y bar, which is 2.792 squared. So the moment of inertia of the plate with respect to the x prime is equals to 145.4.2 inch to the power of 4. Okay, so that is for the plate. Okay, so ngayon naman for the composite area, so we'll just add the moment of inertia ng dalawa. So Ix is equals to that is Ix prime is equals to, so first is 472.3 inch to the 4 plus 145.2 inch to the 4. So the Ix for the composite area is equals to 617.5 inch to the power of 4. So that is the first na hinanap natin, no? Moment of inertia of the composite area. So next naman is the radius of gyration. So radius of gyration is kx prime is equals to the square root of ix prime over a. So we have now the ix prime, which is 617.5 over the area, which is 17.95. Ito. So 17.95. So the radius of gyration is equals to 5.87 inches with respect to x prime. So meaning somewhere above the the axis. Okay, so that is for the radius of gyration. Okay, so yun lang. So ganun lang. So it is a step-by-step process. So as long as you understand the concept, so masasolve nyo yung problem, no? Okay, so these are our references. So that ends our module 6. So thank you for listening and have a good day.